Hi everyone, welcome to Cyber Gurukul. In this episode, we would be discussing one pretty common spring interview question, especially for beginner and intermediate level interviews. So it's to test your understanding of scopes and how they relate with each other. So let's understand the problem first. So singleton, as we know, is the default scope in Spring, and it means that we would be having a single instance of the Spring Bean for IOC container. Now these beans they get instantiated on startup by the IOC container, and as soon as they are instantiated, they will be cached. In order for it to get instantiated, all its dependencies need to be instantiated as well. Okay, so once everything is ready, they will put it in cache, and then whenever you request a singleton from anywhere in your application, the cached copy is what is retrieved and used. Okay, prototypes. Prototypes are per request. What I mean by that is whenever you request the IOC container for an instance of the prototype, it will create a new instance and return it back to you. So whenever we mean instantiation, it means the same thing. The IOC container is the actual one who requests the constructor to return a new instance. It's just that we don't use the new keyword ourselves, but behind the scenes, that's what's happening. Okay, so for a prototype, a new instance would be created per request. For a singleton, it is a single instance which will be used for all the requests that we are ever going to have in the particular application. Okay. All right. So let us try to understand what happens when we have a singleton. Let's quickly jump to our IDE here to understand this. So I have created a Spring Boot application, basic Spring Boot application, and I'm auto wiring a singleton here. I have exposed a method which will use the get prototype method of singleton. We will go to that singleton class in a moment. Okay, and we'll just see if they are the same. Coming to the singleton class, we are auto wiring a prototype, and the prototype class is pretty straightforward. It's a component and its scope is set to prototype. Okay, and I have put a sysout within the constructor just to understand whether this particular class is getting instantiated. That is, whenever an object is created and the constructor gets called, a sysout gets printed out. It's good for us to understand the flow using this. And the same thing here with singleton. And there is this get prototype method that was referred from here. Okay, so pretty basic application here. Now let us see what happens when we run this. Okay, so let's say run. Okay, as expected, the singleton has automatically been instantiated because it was auto-wired, right, into our Spring Boot application. And the prototype bean has also been instantiated because it was auto-wired into the singleton. Okay. Now, even though we have set the scope here as prototype, what will end up happening is this particular bean, whenever we request this prototype through the singleton, it will not behave like a prototype because the cached copy of the singleton is returning the same prototype that was instantiated as part of the instantiation of the singleton. Okay, it'll make sense in a minute. All right, so we hit the endpoint here, and we can see that we are getting the same prototype returned every time, and it is the same one which has been created on startup. So 98D, and that's the same one here. All right, so I think we understand the problem that we are facing here. So only one call actually went through to the IOC container for instantiating the dependency. We can see that the prototype is directly getting returned here, right? And the sysout that we had in the constructor only once. Okay, so this prototype was instantiated on startup. injected into the singleton, and the singleton was cached, and that is what we keep getting every time. Now, with this, we know that we cannot use this auto wiring approach to get prototypes if that prototype is injected into a singleton. Okay, so we need a different approach in order to have that prototype actually work like a prototype. For this, we would need to find a way to request the dependency dynamically at runtime. Whenever we need it, we will request that particular bean be magically provided to us somehow, and Spring works its magic. Okay, so there are different approaches we can follow for this. The most straightforward one would be to explicitly request application context or the bean factory for the prototype class. Okay, we can do this. We'll see an implementation of that shortly. There Another way that we can do this is we can have some object factory methods do it for us internally. This object factory method implementation, which is provided by Spring Framework, is going to use the bean factory, and it is going to request the bean factory for this. So whatever we are explicitly doing with approach 1 would implicitly get done with our second approach, that is using the object factory. Okay, the same thing can also be done using the provider implementation, which is provided by Java X under the inject package. Okay, and then we can use proxies on the singleton side or prototype side. Um, I guess it would be much more easier to understand when we see this in action. So let's quickly jump to the IDE and try to get this implemented using the first approach, that is using the application context. So in order to do this using the application context, first of all, we do not want auto wiring here. Second, we need access to the application context in order to be able to request something from the application context, right? That makes sense. So let us create a utility here. Let's just keep it simple. So we will create a utility. Let's call it bean util. Okay, and we will want to implement one interface here. So we want the application context, right? So we will want application context aware, this interface to be implemented. Okay, so implementing the application context aware interface will give us access to the application context. Okay, so this set application context method will automatically be called by the IOC container when this bean util gets instantiated. We want it to automatically be instantiated at the start of the IOC container. So let us add the annotation at service. So this bean util will get instantiated, and IOC container will automatically call the set application context. Maybe we should create a all right application context. Okay, fine, and we will just set it here. Okay, and we need to have a method which we can use from the singleton class in order to get the bean, right? So let's make it generic. Let's make it generic because we can use the same method to request other classes as well. Basically, that any class that is managed by the any class that is managed by the container. Okay, the IOC container. So we will make it generic here. Okay, give me a minute. Looks like yeah. Okay, a few imports here. Oh yeah, we need to return All right. So return application context. Mm, oh yeah, right. Fine. Okay. Oh yeah, I was trying to have a static method here so that we don't need to instantiate a bean util. So that does not seem like a bad idea. Let's go with that. We will need to make this particular variable static as well. Okay. Okay. So coming back to Singleton here. So it's not autowired anymore. So if we start right now, then the prototype would be null because prototype would not be instantiated. Okay. So in order to make sure that we have something here, let's say prototype equal to bean util dot. Okay, let's run our code and see what happens. As expected, the prototype has not been instantiated on startup because it's not autowired anymore. Okay, and now let's see what happens when we call the method. So we can see that two different instances of the prototype have been instantiated and returned. Okay, I mean we haven't yet seen that it has been instantiated yet, but now we do it. No, sorry, now we see that it has been instantiated. Sorry for that. I guess I got too excited there. Anyway, prototype being instantiated. This is coming from our constructor. Okay, so it has been called twice. Now, if we call it again, we can see that new instances will be created. You can see that the numbers are changing here, right? Okay, so that's how we implement this using application context. There are a couple of other methods in which we can follow the same overall approach, but we would be using a factory class instead. So let's see how that works. Quickly, let us jump to the slide here for a minute though. Okay, we saw this in action. All right, so using object factory, here we will use the object factory implementation that is provided by Spring Framework or the provider framework. Okay, the provider implementation which has been provided by javax.inject. And internally, like we discussed a few minutes ago, the object factory actually gets it from the bean factory. So let us quickly see that in action as well. So we don't want to autowire the prototype here either. We want the object factory, right? So let us create a variable here, a member variable. Okay, and we want to autowire this. Of course, we will have to import this first. So don't use the one given by Sun. Apache, use the one by Spring framework. Okay. And we don't want to do a bean util.get bean. Instead, proto object factory dot get object. So notice here that because we have used generics here, we don't need to do any kind of casting. The object that we will get back is of type prototype, which is what we wanted in the first place. Okay, so let's see how this works. We expect it to work exactly the same. Okay. So a singleton got instantiated here, and then we go ahead and make our request, and it seems to be behaving in the same manner. So we can see that there are multiple instances of prototype created. Great. Now let us try and go to the next approach. I'm going to autowire a provider. Going to use java x.inject provider. Okay. And we are going to prototype here. So proto provider. And we will use, instead of a prototype object factory, let's use a proto provider. And the method name is get over here. As you can see, it's behaving in exactly the same way. So we are getting multiple instances. Only the singleton is instantiated. So we know three ways of solving this problem. Okay, now let's go to something a bit more interesting. So lookup method injections. So in this, we will create a method which is annotated with @lookup to inject the dependency. Now, whenever Spring will see this @lookup method, it will create a dynamic proxy of that particular component, of that particular class. And in this dynamic proxy, what would happen is both the bean and the method, uh, sorry, I was just reading from the slide there. Give me a minute. So in this proxy that is created, try to visualize this for a second. So all the requests that will go to the proxy, because it's a proxy that actually gets instantiated at startup now. And this proxy will send all the non-lookup methods to the original class, but it will override the override the @lookup annotated method. And by doing this, it can request the prototype class for a new instance every time. Okay, so let us see that in action here. So it'll be a bit more clearer. So first of all, we don't want all this. Let's remove them from here, and let's clean this up. All right. Now we will create a method. Okay, pay attention that it should be a public method. Okay, why it should be public must be pretty clear to you guys. We are going to actually have an implementation which is automatically created by Spring, subclass this particular class, and it is going to override this method, right? So for overriding to take place, this method has to be public. Make sense, guys? Let us just import this annotation. Fine. Now let us just put a sys out here, because we want to see if this particular method gets called, right, in proto method. And I'm just saying return null because I expect that this would be overridden by the Spring framework. Let us see what happens here. Okay, we don't need this commented code here. We'll just remove that. Fine. So of course we need to use this method. Okay, so we are ready to run this. Let's see how it works. Hmm. So as we spoke about a couple of minutes ago, it's the singleton enhancer by Spring CGlib which has got instantiated. It's not the singleton class anymore. This is the dynamic proxy which was created by CGlib. Okay. Now let's see what happens when we call the method. It's behaving the same way. It's behaving in exactly the same way here. So whenever any request comes to the singleton and this particular method gets called get prototype, this particular class, the singleton enhancer by Spring, sends the method call to the parent, to the get prototype method. All that is fine. The prototype method will call the proto method, which is overridden within the singleton enhancer by Spring. If it was not overridden, we would see this particular sysout. That's not here anywhere, right? And on top of that, we would have a null return. So we would have in get prototype returning null, okay, which is getting printed here. But this particular method is not getting called. That's pretty clear from the missing sysouts and an actual value being present here, right? So that's what's happening here behind the scenes. So instead of having a dummy method body, we can also have an abstract method, but then it would introduce its own complications. See, if you are having an abstract method, that means the particular class which has the abstract method needs to be defined abstract as well, right? Now, what does the abstract keyword with respect to a class mean? It means that we do not want to be able to instantiate this class at all, right? There would be other implementations which would actually extend this abstract class, and that is where all the abstract methods will be implemented, and that's what we want to be able to instantiate, right? So even if we have this at the rate component notation on top of singleton, if it is defined as an abstract class, the IOC container will not instantiate it anymore. It makes sense because it cannot be instantiated, right? It's an abstract class. It doesn't make any sense to have a copy created in the first place, and that cannot be done either. Okay. So if we make if instead of having a body like this, if we will make it abstract, we can still do it, but we will have to jump around the hoops a little bit. Okay. So we'll have to do a few things differently. So we are not going into that right now. Also, lookup methods cannot work with runtime generated beans using factory methods, and it can only work with beans that the container is in charge of creating the instances for. This is straight from the Spring documentation, and basically what they are trying to say here is that in order for us to be able to use this lookup method injection approach, we need to work with beans that are already held by the Spring container during startup itself. Okay, because our we would be having the proxy which is created at startup, and then this method flows through, and then it is this lookup method is trying to look for a prototype, and this prototype is again something which is already managed by the container. But if instead of this prototype which was already defined here, if we had something which was dynamically returning the values like dynamic at the rate bean methods, then that would have created some complications with respect to this automatic generation of code. At least that's what I understood. um, I'll try to do some research on this. If I'm mistaken, I'll get back here with some clarifications, and I will modify this video. Okay, that said, this proxy approach can be done on the other side as well. That is, we can have a prototype proxy as well. So let us quickly see what that entails here. So if we use the scoped proxy mode, that is the prototype being proxied approach that I was just talking about a few minutes ago. So here, what will happen is the prototype proxy will get injected into the singleton. Okay. So when this prototype proxy actually gets injected, at that point of time, it is something which is cached, right? So if the prototype proxy has been cached already, then how will that work? So basically, whenever the proxy gets called, at that point of time, in order to get a reference of the original prototype, the proxy will make a call to the prototype. Okay, so we'll see this in action. It'll be much clearer when that when we do that. So for this, let's go to the singleton. We want to wire this. In fact, this approach is the closest to the original approach because we would not have anything like this. We would not see the singleton class looks exactly like it did at the beginning of this video. So we have a prototype which is autowired. Then we go over to the prototype and we modify this scope. Okay. So let's add something here. We want to add a proxy mode. Okay, I don't know why autocomplete is not working, but probably some inputs. This is how it looks like if I'm not mistaken. Let me quickly see what is happening here. Oh yeah. Oh yes, right. When I'm having multiple values, I cannot give this directly. I will have to say value equal to scope dot prototype. Okay. When I had only one value at the rate scope and directly specifying prototype, there was sufficient. Okay, so that's all that we did here. Let us see what happens. Okay, so looks like the singleton has been instantiated, but I said that this prototype proxy is going to get injected. Yeah, the prototype proxy is what is going to get injected, and uh, I am not sure why the sysout didn't come, but well, this was something which was added by us, so maybe it's not doing a super dot here. Um, anyway, okay, let us see what happens when we call the method. Okay, so the method is working fine. It's working as we expected it to. But there seems to be something weird here. If you see Proto 1 gives a different instance number, Proto 2 has a different instance number, but Proto 1 equals Proto 2 is true. Okay, that's weird. That's weird, right? So let us see what is happening here. We will just launch it in debug mode for a second. And let's add a breakpoint here. Yeah, there's a breakpoint already here. Fine. Okay. So let's see what is happening. We have proto1 singleton.get prototype. Okay, we can see that it's a prototype $enhancer by Spring. That is, it's a proxy. Okay, as we expected. And then proto2 is another call to get prototype, and it's that proxy again. And it looks like it's the same instance of the proxy F1D4EE71, right? Yes. So it's the same instance of the proxy. So that explains why proto1 equals proto2 is true, because it's actually the same instance that is being returned every time. If you remember at the beginning of the video, we spoke about how a singleton is cached, and the proxy, not the proxy, sorry, the dependency, if it is auto-wired into the singleton, that is what is getting returned every time, right? So this proxy is what got autowired into the singleton, and that is being returned every time we refer to it. Okay, but okay, see here, see, look at the console. See that there is something weird happening. Whenever I refer to proto1, even in my IDE, just so that I can see what is within proto1, a new instance is getting created here, right? So this is how the implementation behaves. Okay, so whenever the prototype enhancer by Spring cglib, this particular class gets referenced in any way whatsoever, it will send through a request to the prototype class, and it will get back a new prototype. Okay, and the constructor is being called so many times, we can see that in action here. All right, so I guess that's it. That's all that I had in mind, and I hope this helped you understand what is happening behind the scenes with these different approaches and why they are working. Okay, if you have any questions, any comments, or any suggestions for improvement or for further topics, then please leave them in the comments below. I will also leave a link to GitHub and a blog article which explains the same in a bit more detail. Okay, the same topic in a bit more detail. Thanks a lot and have a nice day.